Oh shit. Science, bitch. Hey! Hey!
Hey, Vsauce, Michael here. Why, though? Why are any of us here? What's the purpose? What does it all mean? Well, sometimes, if we listen closely enough,
Let's
when
see
we
if it's
ask
anything interesting.
why, we can hear an answer. And it's another question.
Welcome to
Why?
Uganda.
Why what? Our journey begins
Welcome
here.
to Uganda.
Checking the rule book, but you won't find anything in there that says a dog can't play.
He's right. Ain't no rule said the dog can't play basketball.
Is that true? Is there really no rule against a dog playing middle school basketball? Vsauce Magic 8 Ball. Is there really no rule against a dog playing basketball? The answer is yes. Or is it? We have begun. The actor who played Airbud, Buddy the dog, passed away in
I remember this movie.
1998 at the age of 9. Now take a look at this. Let's talk about World War I.
What the fuck is this?
On June 28, 1914, Franz Ferdinand, the heir to the throne of Austria-Hungary, and his wife Sophie were assassinated in Sarajevo while riding in a car. The car's license plate was AIII 118. They were killed by Gavrilo Princip, who said during his trial that he wanted the unification of all Yugoslavs, free from Austria. The event sparked a series of escalations in Europe, the July Crisis, which ultimately caused World War I, a war that ended on Armistice Day, November 11th, 1918. Pretty odd, huh? A spooky coincidence, if you will. But look, odd things happen all the time. Oddness is all around us, especially in the form of odd numbers. The grip they have on our reality is revealed when we release our grip. Notice anything strange? Under the influence of gravity, things move in an odd way. If something starts moving because of gravity, after, say, 1 second, it will have traveled some distance. Now, interestingly, during the next second, the distance it will travel will be 3 times as far as it moved during the first second. During the third second, it will travel 5 times as far, then 7 times, then 9 times, 11, 13, 15. Now, we used seconds, but it doesn't matter what time interval you use. You will always find this pattern, the odd number rule, hiding right there within the very phenomenon that keeps us on Earth are the odd numbers. More like God numbers, right? Is the odd number rule the face of the universe looking back at us? Well, here is something that Galileo wrote. Philosophy is written in this grand book, I mean the universe, which stands continuously open to our gaze. But it cannot be understood unless one first learns to comprehend the language in which it is written. It is written in the language of mathematics, and its characters are triangles, circles, and other geometric figures, without which it is humanly impossible to understand a single word of it. Without these, one is wandering about in a dark labyrinth. Before this pattern in the grand book of the universe was
I just want to know,
appreciated, people
is there a rule against dogs
why
playing
things
basketball?
fell. Maybe stuff just has a desire to be in its own proper place, right? Rocks with the earth, fire with the air. That makes sense, right? It was fun to imagine causes and write our own stories. But underneath our desire for explanations, a story was already being told. One that is written in the language of mathematics. Measure.
He will tell you by the end.
Now, many of these stories are being told all around us all the time, one on top of each other. But if we can look past those disturbances, each isolated event is narrating a quiet, simple story. Not of why the universe is, but of what the universe is. Galileo recognized what this pattern spelled. Mathematically, it spells, hello, I am speeding up at a constant rate. And that was huge. All this time, for millennia, we had been wondering about the causes of gravity, its cosmic purpose, why it existed. But now, here was someone saying, yeah, cool, but like, what does it do? It makes things fall, great. Well, what does that mean? What does it mean to fall? Fall how? Now, the human mind alone couldn't answer that, but the universe was telling us. We just had to speak its language and read it.
Right,
this is, I am gaining velocity at a constant rate, spelled with odd numbers. How? Well, what's an odd number? The concept of oddness comes from the observation that sometimes when you have a bunch of things, everything you have can be paired up. But sometimes that can't happen. Now, when it's possible, when you can pair everything up that you have, it is said that the number of things you have is even. If you can't do that, then the number of things you have is odd. Now, what this means is that the number of objects in an even group is equal to 2 times n, where n is just the number of whole pairs that you have. So n is any whole number. N could be, for example, 50, giving us the even number of 100, which is also the number of legs centipedes have.
Odd is 2n plus
Or is it?
1.
Centa 100. Pede feet. Having 100 legs is right there in the name. But it's only approximate. Centipedes have been observed to have anywhere from 30 to 345 legs. Now, 100 falls pretty nicely in that range. But every pair of legs on a centipede is attached to a body segment, which means that in order to have 100 legs, a centipede would need to have 50 body segments. But not a single species of centipede has an even number of body segments. 50 segments is nowhere to be found in the library of centipede genomes. So, while centipedes, on average, have a number of legs quite close to 100, they never naturally have exactly 100. Point is, 2n is the mathematical way to spell even. If I add just one more thing, the amount I have is no longer even, it's odd. If I add yet another thing, I've added another pair, n has gone up by 1, and the number is even again. This means that an even number plus just one more will always be odd. Now that we know how to mathematically spell odd and even, we can move on to moving. If you and me hugged, well, that would be wonderful. We would both get so much out of it.
And Corona.
But if during the hug you suddenly ran away from me while yelling, I'm leaving you at a velocity of 2 meters per second, well, I would be devastated. But I would know that deep down you still cared for me because you told me your velocity. And if I know your velocity, I can know just how far away you are from me at all times. All I have to do is take your velocity and multiply it by the number of seconds that have elapsed since you left. Now take a look at what a graph of your velocity would look like.
Is this
Here
guy
we have
doing drugs
velocity
nowadays?
in meters away from me per second, and we have time in seconds since the hug ended. Now, if your velocity is 2 meters per second and that persists, then here's a graph of your velocity. But look at this. After a number of seconds have elapsed, like after 1 second, the distance you are away is just the rate times the time elapsed, 2 times 1. Well, that also happens to be the area of the rectangle bounded by a line coming up from the time, your velocity graph, and our axes. Well, that's pretty convenient. After 2 seconds, you are 2 times 2, 4 meters away from
back to
which
back.
is also the area of this shape we've created. After 3 seconds, you are 3 times 2, 1, 2, 3, 4, 5, 6 meters away. It's always the area. Well, that's pretty convenient. But let's change up the story. What if we hugged and it was great? I mean, just almost not even a hug, like something new is being invented here. But then, during that, you suddenly leave. You run away from me. And while you run, you yell, I am leaving you at an ever-changing velocity.
Stop.
Well, I would say, you know what? That is a lot less helpful. Now, let's say that this changing velocity you have, that I don't know, happens to be an acceleration of 2 meters per second per second. What does that mean? Well, that means that your velocity is getting bigger by 2 meters per second for every second that you run. It would look like this on a graph. You begin hugging me with no velocity, and then 1 second later, your velocity is 2 meters per second larger. So 2 larger than 0 is 2. That's your velocity after 1 second. After 2 seconds, your velocity is 2 larger still, so 4. And then 6. Your velocity graph would look something like this. But now here's a question. If you're moving like this, is the distance you are away from me at any given time still just the area of the shape bounded? It's harder to see that because you don't maintain any single velocity for any amount of time. Your velocity is always changing, so we don't have nice rectangles. But we can see that it is true by putting ourselves in my shoes. Abandoned, alone. I don't even know your motion. I don't even know how you're accelerating. It's very scary. But I can decide to take matters into my own hands and measure your velocity as often as I like. Let's say that I measure it just once. I measure it after, let's say, 2 seconds. All right, wonderful. Now the question I want to answer is how far away you are after 3 seconds. All right, so I have this measurement. I know that you were traveling at 4 meters per second. Well, I mean, look, if you're going 4 meters per second for 1 second.
Like what? Is this just a math class?
That's a rectangle like this.
Like what?
It's got an area of 4. But you're not 4 meters away, are you? You're a lot further than that because you weren't traveling 4 meters per second for this entire second. You were at all times actually traveling a bit faster. And I'm totally forgetting all the distance you covered before my measurement, which is not 0.
You make a big fucking
Okay, so
rectangle and
clearly
you
I
fucking
need to
cut it
measure
in
your
half.
velocity
2
more
triangles.
So let's say that I
Okay.
measure your velocity twice
Half
during the
this.
3 seconds I'm curious about. Let's say I measure it after 1 second and then after 2 seconds. Well, now I can imagine rectangles here. This one is 2 by 1, so it has an area of 2. This one is 4 by 1, so it has an area of 4. 2 plus 4 is 6, but you're a lot more than 6 meters away as well, because you weren't traveling 2 meters per second this entire time. You were actually speeding up, covering more and more distance. I'm totally forgetting all the distance you covered over here. Basically, this method will always leave me short. But the more frequently I check your velocity, the better things get. Take a look at this. Oh, yeah. Oh, wow. As you can see, the more frequently I check your velocity, the closer my calculation gets to being based off of what you really did, your actual motion. But also, the more frequently I check your velocity, the closer the combined area of all of my rectangles gets to simply being equal to the actual area bounded by your velocity curve. Which means that the area under your velocity curve, even when your curve is like this, is still totally the distance you are away from me. Now let's take this knowledge and apply it to the odd number rule. Before people knew how things fell, there were some pretty good guesses. For example, if the reason things fall is that they have within them a desire to be in their own
They
proper
can learn
place,
to pick
in
themselves
this
up
example,
again.
the table. Well, then maybe the closer this object gets to the table, the more excited it is to be there, and the faster it goes. In which case, its velocity would change over time like this, getting steeper and steeper and steeper. But Galileo didn't think that. He believed that when objects fell, their velocities increased at a constant rate. So graphed like this, their velocity would just follow a straight line. Let's draw a straight line. Beautiful. Now, let's divide this graph up into strips of equal time. Perfect. All right, now, as we know, the areas of the shapes we have bounded here are the distances traveled during their respective time intervals. So what's the area of our first shape here, a little triangle? Well, we don't know what it is. We don't have any actual markings here on our axes, but that's fine. It doesn't really matter. We'll just call this 1. So in the first second or the first time interval, our object traveled a distance of 1 unit of space. Yeah. Perfect. Now, how far did our object travel during the second time interval? Well, that distance will be equal to that area. Well, what is this area? Well, one thing we can do to make this easier is to divide the shape like this. Now we have 2 shapes, a triangle and a rectangle. This triangle has the exact same area as our initial triangle. That's because they are congruent triangles. They both have the same base length, and because this velocity line has a constant slope, it rises the same amount per time elapsed all the time. So their heights are the same, and they're both right triangles. Their areas are the same, so the area of this space is the area of that triangle plus the area of this rectangle. What is the area of this rectangle? Well, one thing we can do is divide the rectangle in half with a diagonal like this. And look what we've created. This triangle has the exact same area as our initial triangle. It has the same height, it has the same base, they're both right angles. And look, the same goes for this one. It's a right triangle. Its base is the same as this base, its height is the same as this one's height. Gosh, this is just the area of the initial triangle, but twice. So we have two of them, and we have two of them one time. Okay, perfect. Now let's move on to finding the area of that shape. Once again, I can divide this shape like that, and now I have a triangle.
Oh my
because we know
god.
that
Get to the
are.
dog.
So, spiral physics toys, puzzles, projects, you name it. Its mission is to be good for brains. So we give a portion of all proceeds from it directly to Alzheimer's research, and it makes our new Inquisitive Fellowship possible. A program that literally just gives money and equipment and assistance to educational YouTubers so they can worry less about monetization and the algorithm and more about just making the kind of content they want to make and that this world needs. This year's inaugural fellows are fantastic. 12 Tone, Jordan Herod, Of an Atom, and Jabril. You should the Curiosity Box today. Welcome back. Now, Colorado looks like a rectangle, a shape with four sides that all meet at the same angle, but Colorado doesn't have four sides. It has 697, making it not a rectangle, but instead a hexahectaenneaconticaheptagon. And this was all by mistake. The United States Congress initially defined Colorado as a geospherical rectangle, the space bounded by two lines of latitude and two lines of longitude. In the 19th century, surveyors set out to demarcate its shape, to actually mark it on the ground. And they did a phenomenal job with the tools that they had. But mistakes were made. Some were large enough that you can spot them on many common maps of the state. In 1925, the US Supreme Court ruled that the borders as surveyed were the correct ones and would legally stand as the official recognized edges of the state, not the originally intended, theoretically pure geospherical rectangle, thus ending the shaping of Colorado that began with lines drawn by the Compromise of 1850. 1850. We have arrived. Article 18, Section 5, Paragraph 0 of the Washington Interscholastic
here we
Activities
go.
Association 1996-97 Constitution, the set of rules Air Bud would have been subject to at the time and place of the movie, states that in order to participate in an interscholastic athletic activity, like basketball, a student must be a, quote, regular member of the school, defined as someone enrolled half-time or more. The section does refer to RCW 28A225010, a list of approved exceptions, but not one of these was considered in the case of Air Bud. Had they been, it would have been discovered quite quickly that Air Bud the dog qualified under absolutely none of them. There is no rule that specifically states a dog cannot play basketball, but there are, and were rules that said that this dog, Air Bud, should not have been allowed to play basketball. And as always, thanks for watching.
Thanks for wasting my fucking time, bitch. What the fucking Christ. Oh my god. That was the worst Vsauce video I've ever fucking seen. Hellfire Donut says, I can see from your desktop that your PC is definitely 100% virus free. I mean, yeah, pretty much.